Hello, geology students. This is Mr. Whitfield. I'm here to give you a little bit of information about your upcoming lab practical on rocks and minerals. And we're just going to get right into it. And I'm going to share my whole screen here. And I'm going to turn off my video so you don't have to see my charming face, but I figured I would at least introduce myself that way. So I'm going to disappear, and you're going to see on your screen three different charts. These are right out of your lab manual from this course, so you can find these in there. I would actually recommend, if you haven't yet, do what I did, which is download each of the three. This is just for minerals now. And then there are also three for rocks, which we'll look at later in a different video. So we're going to focus on the structure of the lab test here, and I'm going to go through some examples of minerals for you, how to identify them, and what kinds of questions you might get asked. So here we go. So here are your three different charts. They grouped them into three different groups, and you look at minerals in terms of their luster first. So that's the best thing to look at right away when you see an unknown sample. So we have metallic ones, we have non-metallic minerals that are light in color, and then we also have non-metallic minerals that are dark in color, okay? So having these three charts handy really will be helpful. You can use them obviously on the test. So, and they give you all kinds of different information that will hone down the actual identity of the mineral. So what I'm going to do is pull up a quick document here that I have going. And the structure of the lab test is, it's on Blackboard, and you'll see a very good, clear picture such as this one with a sample on it. And it's going to be, hopefully obvious what it is if you've done a little bit of studying. But if not, you can certainly look down here. You'll always see a fact of some sort about the mineral to kind of steer you in the right direction. For most of them, at least. Some of them are so obvious that you'll probably just know it and there won't be a hint. But you're going to basically be asked a few different kinds of questions. The first one we're going to do is actually number 3 here. We're going to try to identify this mineral based solely on what we're looking at and that one fact. And we're going to use the charts that you have been provided to do that. So let's take a look. Now, would you, if you were to look at this, think it was metallic or non-metallic? Well, metallic means it looks like a piece of metal, meaning it looks like aluminum foil or stainless steel or a copper penny or gold jewelry or silver jewelry, something like that, or maybe even a brass musical instrument. This does not look like any of that. As a matter of fact, it almost looks like its light can pass somewhat through it, so it's translucent. So that is not the characteristic of any metal that I know. So I'm going to go with a non-metallic. And then if you look at this in terms of color, you can definitely say this is a lighter color, like it's pink. So pink and white and powder blues and things like that. Some of the light colors would be found on that specific chart. So we're going to go with light in color and non-metallic. So that means you have to pick which chart to go to. And so that would be this one. So I'm going to drag that up front here and hide these two behind it so you're not getting confused. So here's your chart that we're going to use. Oops. Okay. So what we're going to do is, now we know it's non-metallic and light in color. It said, I believe in the hint there, it said it was harder than glass. So that actually is one of the classic giveaways of what you might be looking at. So that puts us up, and it already narrows it down to just 3 choices. So you have your feldspars and you have quartz. Now let's go back and look at that picture one more time. And we need to decide, does this have a cleavage pattern? That is the next best thing to look at in terms of identifying a mineral. And so what I'm looking for are kind of either smooth, flat sides that are parallel to each other. I might be looking for, even within a mineral like this, cracks that look parallel to each other. I might be looking for a shine across the entire surface that I'm looking at that is consistent, like a glare that happens across the whole thing. And what I'm seeing here is basically none of that. I don't see, I see a flat-ish looking side here, but I don't see any other ones that are parallel to it. I also don't see the shine coming from it in terms of, like, if you think of that time you leave your phone in the passenger seat while you're trying to drive, and then the sun hits it just the right way, and the light bounces off and into your eyes, and it's horrible because you're driving. you want to see that glare that's consistent like a mirror almost across the whole side, and that would be a giveaway possibly of a cleavage pattern. And I don't see that. I see it's a very irregular looking surface that has even some curved fracture lines in it from when it was broken off of wherever they got it from. Um, and I said the word fracture because that's what this pattern is. This fracture is the absence of a pattern of cleavage. So that's what we're looking at here. This is a fracture pattern. So that basically already has helped identify what this mineral is. If I can get the charts to go back up here. So the two choices for the feldspars, potassium and plagioclase feldspar, both have cleavage patterns, which we will see in a different sample here later. So we have absent cleavage, which means we are looking at quartz, and that's how you would identify that mineral. Okay, so that's how we figure out that one. And then there's a couple other questions about it. It says, based on evidence from the photo, this mineral shows which of the following? Well, I kind of already went over the answer to that, but look at the different choices. Cleavage pattern is a definite no. Fracture is the answer. That's what we just determined. Softer than copper. Well, copper has a hardness of 3.0, and we said that this was harder than glass. So that's a minimum of 5.5. So it is not softer than copper. It's actually much harder than copper. And we also said definitely not a metallic luster. So when you get the lab tests practical, you'll probably get a couple of questions like that one. What gives this mineral its high hardness? Well, what gives a mineral any property that it has, whether it be the color or the luster or the hardness value or the cleavage pattern or not cleavage pattern? The answer is always the same, and it's this. It's the internal arrangement of its atoms. And that is what causes a mineral to have every property that it could possibly have. It's based on what atoms are in it and how they are arranged. Okay, so if you get any question, like say what gives this mineral its glassy luster? Well, it's the same answer. So it's going to be the internal arrangement of atoms. Be on the lookout for that. We identified it already. And then the other big popular questions you'll see through some of the lab practical is uses. So what is that mineral used for? I'm giving you a couple of slideshows that have, if the mineral does have a use, it'll say what that mineral is used for. You can look it up. Sometimes it might say on certain, if you have different identification charts that you're using that you're comfortable with, it might actually just say what the use is on those charts. But if you look around in the world of the internet and on various identification charts, you will see that quartz, which we were looking at, is used for making glass. So that's going to be the answer to that question. So I want to do another one with you. And so this is a new picture, and we're going to use the same three charts, and we're going to figure out what this one is. So again, I want you to look at it and say, does this have a metallic or non-metallic luster? And again, does it look like, stainless steel or gold or silver or brass? And the answer is obviously not. You can actually see light is coming through it again. So that is a translucent kind of mineral sample, and that means it is not a metallic luster. So once more, we're going to pop over to our charts here and figure it out. So let's see here. We have non-metallic light color, non-metallic dark color, and then we have the metallic ones. Well, this one is definitely a lighter in color mineral, so I'm going to use this one again. And the hint says it reacts with acid. Before I switch back to those charts, I want you to look at this and compare it to the one we just saw, which up here, and look at the difference in the surface. You can see there are very flat, smooth sides. You can also see that there's parallelism going on. So this little, I hope you can see my cursor, at least this thing right here, this top side, I see another crack in this mineral that's parallel to that, and it's also sitting on a table because the bottom side is parallel to the top side. So that is a dead giveaway for cleavage. And if we were to shine light on this, you'd see a very broad reflection, kind of like a mirror, where you would see that consistent glare. So that is a giveaway for cleavage pattern. So I don't even care really as much about this reaction with acid as I do that cleavage pattern. That's going to help me really quickly identify this mineral. So let's go ahead and do that now. Now we don't have a hardness value on this, okay? So that means you got to be a little more clever, creative as to how you go about the final identification. But I will say we just narrowed down. It could be something that has a cleavage pattern. So that's either potassium or plagioclase feldspar. We also could have calcite, halite, fluorite. We also could have muscovite mica or gypsum. So that is a little bit not helpful. We have quite a few options, but you can eliminate some of them by process of elimination. So, I mean, let's look at, say, fluorite, yellow, purple, green, or colorless. That I don't think that particular sample fits some of those descriptions. Look at muscovite mica. You have colorless or opaque, it says transparent and elastic and thin sheets. I don't really see thin sheets in that picture. And if you've ever seen mica, you know what I'm talking about. I mean, I see a couple of different options that look like it could steer me towards it. But what I'm going to finally point out to you is I gave you that hint for a reason. If you actually look at the fact right there that I've highlighted, it says effervesces in hydrochloric acid. So that means it's reacting or bubbling, kind of like Alka-Seltzer. And that's definitely a giveaway for calcite. Now, I did that on purpose. I made it a little more difficult. What I could say, I would say, and maybe as another possible hint, that it's maybe softer than glass, or maybe softer than, or about as hard as a copper penny, which is about a 3.0. So I could give you some more hints on that mineral that weren't that vague. But anytime you see any kind of reaction, it's probably calcite or dolomite as the final answer. Okay. So, you know, we could ask the same questions about this mineral that we did for quartz, but the answer here for the evidence in the photo, the most obvious feature of that mineral is its cleavage pattern, as we said, and it's more than one direction. We've got a kind of a parallelogram shape going on, so there's two different directions of cleavage. Where halite, if you were ever to look at halite looks like cubes, so it's basically all the same kind of 90-degree corners. This doesn't have all 90-degree corners. It is kind of a squished and kind of almost slanted pattern of cleavage. Okay, so it does have one though, so that's the answer to that question. This question is irrelevant because it doesn't have a high hardness. So I would ask maybe what gives this mineral its very distinct pattern of cleavage? Well, the answer would still be internal arrangement of atoms. Identity, we figured out it was calcite. For the use of this one, there are a couple of different uses for calcite. I think you might see sometimes pottery. So that's the best answer out of this group of answers. The other big one is it's used in concrete in making cement. Okay, I've got a new sample for us to identify here. So let's take a quick look at this one. And I hope that and I did not give you a hint at all on this one. Just what's the most obvious thing you're looking at? There are two very obvious things, but probably the most obvious thing is that it kind of looks like a chunk of shiny metal, like it's a silvery, shiny kind of surface, and it's very clear that light is not going through this. So I would say I'm looking at one of the metallic minerals. The other thing is, if you look carefully across this mineral, you see a lot of 90-degree cubic corners on this, and even cracks that look like they might break away in a pattern. Well, that's a cleavage pattern, and that's what you're looking at. So I see two big things right away. The metallic luster and the cubic cleavage pattern on this are really dead giveaways on what the identity of this one might be. So let's go back to our charts and kind of narrow it down. We are not in the non-metallic charts now, because that one that we just saw is clearly a very metallic one. So once again, we don't really have the hardness value on this one. I will say, for future reference, it's pretty soft, believe it or not, even though it doesn't look it. So what we want to do is kind of look at the streak color or the outward color of this mineral. That might be a hint I would give on this. It might have like a dark gray black streak. So that could really narrow down to these three, this one, or the bottom one down here, which is graphite. However, if you read through the different descriptors here. Um, it says stuff like granular, in this case, granular or black. This is not black, and it doesn't have a granular look to it. It has a cubic look to it. And also it says magnetic. Uh, I would say if you had magnetite, your hint might be that it's magnetic. Not going to lie. So I don't think that this one really fits, especially with that often granular look to it. And that's going to make me kind of skip over that one. Golden yellow, hardness of 4, specific red. I don't see that as being yellow, so no. Silvery gray, now that is something that I could definitely get into. And if you read more, it says good cubic cleavage, and that's exactly what we're looking at. So you're actually seeing a sample of galena. Looking on down, black to bronze, definitely not. It says tarnishes to purples and greens. We're not seeing any of that. Down below, for graphite, you do have that silvery gray descriptor, which would make it kind of me want to pick that actually, but it says massive to platy, writes on paper, feels greasy. That doesn't look greasy, I can tell you that. It looks shiny. So you know, you'd have to make that call, but again, I might give you some more hints on that one. But the cubic cleavage thing is, you know, if you end up getting it down to 2, pick the very best answer you can for sure. And that's what I would say there, okay? So that's this sample. And a couple of other questions you could get on that. The use of galena, it's made of lead. Anytime, actually, let's go back to those charts. If you see in your identification chart, there's atomic symbols underneath the name. If you know what those are, like iron and copper, Cu is copper, Pb is actually lead, you can almost guess what the use of the mineral might be. And for galena, it's an ore of lead. So what that means is they dig it up and they kind of melt it down, and the lead will sink to the bottom and the sulfur that's in it will go away. And you can harvest actual pure lead out of a mineral like galena. So that would be the use of that one. Okay, so we're going to skip down. We got one more. Oh, I'm sorry. That's for later. That's rocks. So actually that is it for the mineral identification portion of this little assistance video here. So I will end this, and then we'll do another one on rocks.